Hi, this is Victor and welcome to my math tutoring channel. In this video, we'll do some revision for final exams. I will do a series of final exam revision, and this is one of them. So for integration. Let's start from example number 1. If I have the integral of 1 minus tan x divided 1 plus tan x dx. And I look at this integral. If I take the denominator as u, I cannot get the numerator as du, or vice versa. If I take the numerator as u, I cannot get the denominator of du. So what I will do is I will play with the trigonometric formulas. So I can write 1 minus, I know the tan is sine x divided by cosine x. And then there is this division by 1 plus sine x divided by cosine x dx. So now I will have a common denominator in the numerator and common denominator in the denominator. So if I want to have a common denominator, I will have cosine x minus sine x divided by cosine x division, but by cosine x plus sine x divided by cosine x. And I have dx here. And here I can see I can simplify cosine x. So my integral will become integral of cosine x minus sine x divided by cosine x plus sine x dx. So now, always, the first thing that you think about taking the denominator as u. Almost all the time, this is the case. So if I take my u equal cosine x plus sine x, my du, derivative of cosine is minus sine x, and derivative of sine is cosine x. So if I look at my du, it is the numerator, and my u is the denominator. So it become cosine minus sine, or minus sine plus cosine is the same thing, dx here. So it become du in the numerator divided by u, and this is equal ln of u plus c, and then it is equal ln, I replace u by its value, which is cosine x plus sine x plus c. So the first example is easy, and this is how we do it. Let's do another example. It's a little bit more difficult. So if I have the integral of square root of x divided by x to the power of 3 plus 1 dx. Now looking at my numerator and denominator, nothing that I can take as u will give me the other thing as du. But I know there is a formula, arc tan x is equal 1 over x squared plus 1 dx. I can make this look like it, because I have the square root in the numerator. I can put the square root in the denominator and then put it to the power of 2, and it will resemble a little bit like this. You will see what I mean. If I say this integral will be equal, that's the formula here, it has nothing to do with the equality. This integral will be equal square root of x divided by x square root of x to the power of 3 square plus 1. And I know, like, square root of x to the power of 3 to the power of 2 is x to the power of 3 dx. And now I say let u equal square root of x to the power of 3. So u is equal x to the power 3 over 2. My du will become 3 over 2 x to the power of 3 over 2 minus 1. But 3 over 2 minus 1 is 1/2. Because if I do common denominator, it becomes 3 minus 2 divided by 2 is 1/2. My du becomes 3 over 2 x to the power 1/2 dx. There is a dx here. So my du is equal 3 over 2 square root of x dx, and look at the square root of x dx where it is. There is the 3 over 2 that is bothering me. I will take it to the other side. I'll do cross multiplication. It will become 2 du divided by 3 is equal square root of x dx. So now I can replace square root of x dx by du, and the denominator is gonna be u squared plus 1. So my integral become, I can take 2 over 3 outside because it's a constant, and become du divided by u squared plus 1. And the formula of 1, I will apply the formula that I put here. So this will equal 2/3 of arc tan of u plus c, and I replace u by its value, 2/3 of arc tan square root of x3, square root, not cubic, plus c. And that's my second example. Let's do another example here. The second example that I will do is 1 over sine x cosine cubic of x dx. But I know there is a trigonometric formula that say sine square x plus cosine square x is equal to 1. So my 1 here, I can replace it by sine square x plus cosine square x. So my integral will become sine square x plus cosine square x dx divided by sine x cosine cubic of x. Why did I think of sine x plus cosine x equal to 1? Because there is nothing in common between 1 and sine x cosine x, but if I put sine x plus cosine x in the numerator, I might find something in common. Now I can split my integral because there is a plus here. I can split it. It becomes integral of sine square x divided by sine x cosine cubic of x dx plus cosine square x divided by sine x cosine cubic of x dx. Now this is equal this. I will take that integral of sine 2x sine square of x divided by sine x cosine cubic of x dx, and I will solve it by itself. This I can write it I can simplify sine x here and the square from the top. It become integral of sine x divided by cosine. Instead of writing cosine cubic of x, I will write cosine x times cosine square of x dx. But I know sine divided by cosine is tan. So this is equal tan x, and 1 over cosine square of x become sec square of x dx. Now I can say let u equal tan x, knowing that du equals sec square x dx. And here the teacher sometimes tells you like, I will give you the formula in the exam and student won't study the formula, but like if you don't know that the derivative of tan u equals sec square of x, you will never think that to take u is equal to tan x. You don't need to memorize the formula. You should know that the formula is like close to this, you know? So my integral of tan x sec square of x become integral of u du, which is equal u square divided by 2 plus c, and then I replace u by its value. It becomes tan square x divided by 2 plus c. So this is the first part of my integral. I solved this here. Now I want to solve this part of my integral. I will put this into a square. I will take the second part, cosine square of x. So the second part is cosine square x divided by sine x cosine sine x cosine cubic of x dx. Okay? But the cosine square of x, I can write it cosine of x times cosine of x divided by sine of x cosine cubic of x dx. And now cosine divided by sine is cotan of x. So integral of cotangent of x divided by cosine square of x, because I simplify this by this. But I know the cotangent is 1 over tangent. Yeah? So this, there is dx, this become the cotangent, it is 1 over tangent of x, and 1 over cosine is sec square of x dx. And now if I take my u equal sec square of x, my du, if I take my u equal to, always we take the denominator as I said, tangent of x, my du equals sec square of x dx. So this integral here become du over u, which is equal ln of u, it's a formula, plus c, and then it become ln of tan x plus c. So my original integral will become tan square x divided by 2 plus ln of tan x plus c. So integral of 1 over sine x cosine cubic of x is equal tan square x divided by 2 tan square x divided by 2 plus ln of tan x plus c. And that's my final answer. Let's do a last exercise for this video, because I don't want my video to be very long. You will get bored. And I will do another set of videos for final exam revision. We'll do 1 minus square root of x, and I think this is the toughest, but it's not that tough. 1 plus square root of x dx. Again, as I said, we take the denominator as u. Let u equal 1 plus square root of x. So my u is equal, I want to have a space here. I want to write with a smaller letter. Let u equal 1 plus square root of x. My du, so my u is equal 1 plus x to the power 1/2. Now my du, derivative of 1 is 0, and derivative of x to the power 1/2, it's equal 1/2 x to the power minus 1 over 2 dx. So my du is equal 1 over 2 square root of x dx. Because I bring down the x to the power minus 1/2 to the denominator, it becomes x to the power 1/2, and x to the power of 1/2 is square root of x. But me, I have dx into numerator. Let's calculate dx. My dx here is equal to square root of x du, because I did cross multiplication. So 1 times 1 is 1, 1 dx times 1 is 1 dx, which is dx, and 2 square root of x times du is 2 square root of x du. Now I look at my numerator. I did not, from my u, I couldn't get the numerator, but from here I can know that square root of x equal u minus 1. So in the numerator, I can replace my 1 minus square root of x. I will replace it by u minus 1. And my dx, I will replace it by 2. But instead of square root of 1, I can put u minus 1. Du divided by, I took my u is equal 1 plus square root of u, so divided by u. So here let's elaborate my numerator. It become 1. Actually, I will put parentheses here. 1 minus u plus 1 multiplied by 2u minus 2 du divided by u. So my integral plus 1 is plus 2 is minus u plus 2 multiplied by 2u minus 2 du divided by u. And then let's elaborate the multiplication here. So it become minus times plus is minus 2u square, minus times minus is plus 2u, plus times plus is plus 4u, and plus times minus is minus 4 divided by u du. And here I have 2u plus 4u is 6u. So my integral will become minus 2u square plus 6u minus 4 divided by u. And here I can split my integral du. So it become integral of, I can put minus 2 outside, of u square du plus I'll take 6 outside divided by u here, become u divided by u du, and I can take the 4 outside du. And this become 2 integral of u, because I simplify by u, plus 6 integral, sorry, because the 4 is divided by u. I have to divide the u by 2x squared, by 6u, and by 4. So this is what I am doing. Du minus 4 integral of 1 over u du. And if I want to solve that integral, minus 2u2 divided by 2 plus 6u minus 4 ln of u plus c. And then I can simplify here by 2, and I will replace u by its value. The original value of u is 1 plus square root of x. So it is 1 plus square root of x square plus 6 times 1 plus square root of x minus 4 ln of 1 plus square root of x plus c. And I will end my video here. I will do other sets of revision for final exam, but this is set number 1. If you like my video, please subscribe to my channel, and that will help me continue to do whatever I'm doing, and it will help you understand better your course. Thank you.